I'm here today with the AC0 and I would like to show you how we construct with materials the sail to bring performance. Performance in our case in 0.7, it means wind range. Wind range is the most important thing in a sail. It's the one that allows you to have the most comfort when the wind is increasing, power when the wind is decreasing. So the main focus when we develop any sail is always the wind range. It's what allows us to have less sails in our sail range, what allows you to have less sails in your quiver, so saving money, having more fun, at the same time having the right performance. And materials are very important in the construction of the sail. So having the right materials in the right places, the right constructions, the right reinforcements is actually what allows you to have fun. So if you're comfortable in strong wind, you're going to have a steady stance in strong wind, you're not going to lose control, you're going to control better your board, you're going to push better on the fin, and therefore you're going to have a higher average speed. In light wind, if you have the power, you're going to plane earlier, so again you're going to be competitive in light wind, so you're going from very light wind to strong wind, and this is the main thing. Once you have the power in light wind, once you have the comfort in strong wind, wind range is there, and that's when you have a good product in your hands. When you get the sail, you will see this piece of paper on the sail, and that's because you are buying a sail which is 100% anti-UV material. What it means is that each part of the monofilm is a laminate. A laminate compared to a monofilm is that it's made by different parts. So you can imagine that you have a piece of monofilm on one side, in the middle you actually have glue, and on the other side you have another layer of monofilm. So it's a sandwich of materials, and the glue which is put between the two monofilms is actually an anti-UV glue. The darker it is, the more it will last in the sun, because it's actually protecting the UV rays from going through, and therefore the sail doesn't become crispy and with time just crack. Also in the window, the anti-UV material, most of the sails are transparent, ours is not, because it wouldn't make sense to have like the whole sail anti-UV and then the window which is transparent, and also having then the problem that it gets getting old with the materials in the center. Therefore the sail is at this point 100% anti-UV. When you have a window which is a laminate like ours, in this case it's the gray transparent anti-UV material, which not only has the two monofilm sides, but it also has another shield of metallic monofilm in the middle of the two monofilms and the glue. So it's actually an extra layer. When you have this type of material in the window, it's actually stronger than a normal X-ply material, transparent. And this is why on our AC0, on all our Flatwater sails, we're not using that much X-ply in areas which is not needed. It's only adding like maybe 5 grams of weight, but it's not needed. It's not what we want, also because when you're going to use the X-ply in the middle of the window, you're going to create a stiffer area, which you don't want at this point of the sail. You don't want to have it too stiff here, because that's where you want the power to be, and so that would just damage the performance and the wind range of the sail, while here on the top, in some areas, we are using it for performance. At the bottom panel we have no stitching. This is important for when the sail is on the board that you just fell in. The anti-skid of the board will not scratch and wear off all the stitching. So the insignia that you see here is covering the full stitching which is underneath of the reinforcements. This is very important for saving, therefore, with time, this base area of the sail. And underneath, of course, there are also a lot of Kevlar reinforcements which are going all the way up. So through the sail, underneath all this insignia, and along this line, this Kevlar, which is actually on a no-cam sail, giving more stiffness. Stiffness is important because it gives stability, and are locking in a lot of the power and profile of the sail already from this area of the deck. So if you look here, just under, you will see little threads of Kevlar coming out, because of course it's not easy to, you cannot burn the Kevlar, so there's still a little bit of little yellow lines of the Kevlar which are going all the way to the top. Putting Kevlar all the way up inside here and also having the X-ply here in the front panels is actually creating this extra tension on the sail area in the front, which gives stability. It doesn't allow the sail to stretch too much, losing the control. So what happens is that because we have enough tension with the Kevlar in these areas, we're actually allowed and can allow ourselves to use a luff curve, which is actually not extreme, because if you put a lot of luff curve, then it's easy to, let's say, lock in a profile. But when you put too much, also the feeling of the sail will be stiffer, heavier, and the low end of the sail will actually lose. So meaning that you will have less power in light wind. If you can manage to keep the luff curve straight, first of all, it's also easy to downhaul the sail, and second of all, you're letting the sail allow to breathe. So you compensate the straighter luff curve by using a little bit stiffer materials just at the back of the luff sleeve. Down here at the bottom, we have a Dacron panel, a small one, which starts out wide and goes smaller and smaller and smaller. This is because when the wind kicks into the sail is actually, let's say, blowing up. So when it blows up, this one gives an extra power. So when the sail is bending, the mast is bending, the sail follows. Here there's going to be more profile. This extra profile, which forms thanks to the Dacron, which is a soft material controlled by the X-ply just behind, will give that extra power to get planing. But also what is important about this is the drive. It's going to pull you forward when you sail. So you're going to feel that forward pull, which allows you to accelerate in control. Also because when you have more profile here at the bottom, it's actually controlling the board to be more stable, and it gives a lot of advantages in light wind and strong wind. So it starts off wider, so that the power is more at the base where you actually want to have the power, and slimming down going towards the top. Controlled always also by the Kevlar that you still see here at the back. The material of the mast sleeve is also very important. It's what gives the performance to the sail when it's in synergy with the rest of the body of the sail. So what we have is a very tough mast sleeve material for more reasons. One, it offers more reflex, which can vary. Also just with the color, if you use a white color, it will not be as reactive as a black one because of the pigment of the color. It sounds crazy, but that's how it is. We tested the white sleeves against the black ones, and the black ones had more reactivity. And actually on the race sails it made quite a big difference in acceleration. And so the other thing is that it's nice and strong, so that if you crash the sail, it's not going to open quickly. Visibility is always like you're not actually looking through the window. You might look through the window in the center panel when you're going into a jibe, or because you're looking if there's someone below you. But when you're sailing, you're actually looking always in front. You're always looking in front of the mast. It's really rare that you're looking through the sail unless you're starting to jibe. And the area that you're looking down to is actually not this panel up here, a little bit in this one, but a lot in the lower one, because you're actually lying down, so you're looking under the boom practically. So it's actually more this area here. Now when you look at this panel here, it's an X-ply. So we have an X-ply here, which is very stiff. We have a second X-ply, which is also stiffer compared to a normal monofilm, and behind we have the monofilm. So what happens is that you have a very stiff X-ply as well, a little bit lighter, and the monofilm here, which is a little bit lighter. They're all stiff materials. They are not this 3 mil, 2 mil that some sails have, which are light on the beach, but actually on the water they become heavy because they are not having this reflex, they're not having this responsive feeling, which is what you need to actually accelerate and to have the sail to feel light. This is why we're using a carbon mast, this is why you're using carbon boom, to have more performance, and therefore the material has to have the same reflex. You cannot use too thin materials to save weight and then having a sail which, instead of working and having the reflex, is actually being light, soft. So what happens is that the material, instead of bending the mast and accelerating, they're actually blowing up between the buttons and between the mast. So what you're having is you're having a balloon at the back, and that's what you want. That's going to give you a lot of weight because the power goes to the back, the power goes on the top, and yes, the idea is like we have light material on the top, so that makes the sail light on the top, which is nice on the beach, but not when you're on the water. On the water you need reflex. That's where the light feeling comes, where the wind range comes, and the wind range is the winning component of a sail. So what we have here is we have a very stiff, again, as I said, X-ply to give the stability. This is what this triangle here that you see, let's call it triangle, is also stiff to give, again, an extra stability to the profile. And then at the back we are having a stiff material, but which is allowing to not stretch but to open and keep the position. So these three layers are very important. And between, again, each stitching we have Kevlar reinforcements, which is an expensive material, easy not to put in, but we put it in because what we want is you to have a good wind range in the sails. On the head of the mast sleeve we have a very practical solution for protecting the mast sleeve. Just on the top it's a small rubber tube here just to cover the mast sleeve from scratching. We have the button protectors just on the sides where it's needed. We don't have it on every button. We have it on the top on both sides because this both sides is touching. For example, here we don't have it because it's never touching the ground. So we just put the protections where they're needed, not because we want to save money, but because we want to save weight and useless weight where it's not needed. The mini battens are small at the bottom and getting longer on the top, because also these ones are giving pressure to the leech. And if in a smaller panel you can have an extra button which is a little bit longer to press more on the sail and keep more stability, that is going to give you the stability which is needed for control. And of course, as lower you go, the less pressure the area will have, because on the bottom you have the wind just flying out, and here this is where the area where it's actually more like the winglet and where the sail is moving the most. So you want this to be more stable, and that's why the mini battens are longer. The button pockets are made with X-ply as well, because the transition between one panel and the other has to feel like it's one piece. We tried using Dacron, like you can see on the other two buttons, and you feel the stretching of the material. With the X-ply you don't feel that, and this gives again an advantage in feeling that the sail is more compact, is more direct, accelerates better, and therefore you have more control, more acceleration, and a bigger wind range. Here you might think, yes, but here is Dacron. Yes, it's Dacron because the buttons alternate. So we have one button facing here and one button facing at the bottom. So on the other side is actually having the X-ply. This is just the covering of the X-ply because on one side we are not covering it because it's not needed, and on the other side you needed to cover the stitching between the two panels. Here at the back we are having one Clew. The reinforcement is strong enough and big enough to guarantee the sail having a long-lasting life and from not breaking. We only have one eyelet because the tension that you put in this area of the sail actually changes how the leech is going to open. But if you work with an S shape in the buttons, you will work well in 1 to the millimeter how the sail opens. If you're going to use the eyelet in a different position, it's going to change the performance of the sail, and it can only make it worse. So the best thing is to develop the sail in one position and to create a setting for the leech to have this wind range. So when I'm putting the eyelet here, I know that the sail is going to have a huge wind range because that's how the leech is going to work at the best. If I put it here, the whole tension on the leech when it goes into the wind is going to be different, and it doesn't mean that you're going to have less power, we're going to have more power, you're just going to have something which works less. So having one eyelet is the main focus in our sails, and that's why we only have one. Plus, having less weight at the back, again, gives a lighter feeling. The lighter the sail is at the back, the more you will have a lighter sail in the hands. We alternate the buttons for the reason that the profile then on both sides is more similar. So the sail is actually feeling on both sides the same, and this is important. Otherwise you would need to adjust the power of the sail also according to the side unit you're sailing, if you have them all on one side or all on the other side. So if you alternate them, the power when you switch from one tech to the other feels very similar, and therefore this is one of the reasons. Of course it's a bit more work in production for them, because every time they have to put a button pocket on, they have to turn the sail around, so for sure it's costing also more money than just putting them on one side and that's it. In each button there's a different construction. We are not using carbon tubes. There's no reason to use them, because if they are too stiff, in the end the sail is not breathing. If the sail doesn't breathe, it just kills the performance in light wind. So you want a sail which has glass buttons, tubes, so that they can actually be a little bit softer, follow the performance of the twist of the sail, and therefore you can actually say have a wider range, especially in light wind. And in strong wind, if the sail has character, if the sail is developed as it should be, you don't need carbon tubes. Carbon tubes are often used to, let's say, to modify a sail which is having a problem in blowing up into the wind. So when we look at the top two buttons, we have just a very simple tube. It's a small tube of 11 millimeters on the outside diameter, and it's just a straight tube. And because we want to have the sail which doesn't actually create a profile here at the back, we want nothing even in the front, we want it just to be stable, because it's acting like a winglet, that the wind doesn't go out from the top, because the wind has to go out from this area here. The button 3 and button 4, they have like softer tips to start creating profile to the sail, and a 14 millimeter tube outside diameter at the back. Button 5 is actually a special button. We actually have a 3-piece button, so that the profile is like more constant. It's not having this strong profile in the front. What we have is a tip for 20%. Then we have a 11 millimeter tube of another 20%, and then the bigger tube of 40 millimeters is just at the back. The shape on the top here is just more round. It gives you the feeling to have a mast sleeve, wide like the race sails, and it doesn't give you weight. If you would have also here just a tip and a bigger tube, you would actually have a lot of profile in the front in an area where you just push down the board too much, making the sail feel heavier. Button 6, we have again just a 2-piece button, so a very soft and long tip to give a lot of profile in the front, to give you the drive, the power, the stability of the sail, because the stability of the sail comes from this area. And at the back we are having a 40 millimeter tube, which is also long and just keeps giving this, let's say, profile to the sail. But in the minute that you pull more outhole, it flattens out and it gives you a lot of control, because then the sail does not have a profile at the back anymore. When we go to the bottom button, it is actually just a button tip, a very long button tip, but in the center, so here we have an 11 millimeter tube going over the tip, which makes this center area stiffer. We want that one stiffer because we want that the center of this part of the sail stays more straight, so that the wind is actually going through faster. So we have a nice belly at the bottom, first part, straight area, which then, when it stops here, the tube, it allows also here, when there's wind, and there's a lot of wind, to start opening. If you would have the tube all the way to the end, when the wind, strong wind comes, the sail will just remain closed. It will slow you down, give you extra power which is not needed, and make the sail less stable. Having the tube to stop here and having just the button tip at the bottom, as you can see, it just can open and work as well when the wind gets strong, and so it just makes the sail more comfortable. Again, we go back to a bigger wind range and more speed. Important for us is to give you a sail which is performing the best, so no gimmicks, not extra things just to make it look like there is protection. No, we are using the materials which are needed to give you the wind range. A strong sail, which doesn't give you warranty, a strong sail which lasts with time. So the last thing, of course, is here the base pad. It's of Evergrip. It's also small, meaning that it's not huge, which just takes space in your windsurfing. It's looking bulky. It's something which is practically, it's protecting the board, it's protecting the sail. It has the hole to put in the uphole, It has a nice pocket, practical to stash in the rope. It's put in a way that it's not going to fall out, easy to put in. Tech strap. So everything is thought to give you the best materials, the best performance, and at the same time a long-lasting sail, which gives you the best fun.